All right, this is a video on finding quadratic functions of best fit with an introduction and some examples. In this video in particular, though, we're not going to be working with real-world data that have some scatter. We'll be working with finding in a quadratic function, the equation of a quadratic function, if we're given some particular pieces of that function, maybe the vertex, maybe a couple other pieces. So we're looking at finding equations from some points on a graph. In the challenge video that'll come after this, we'll actually be working with some real-world data and trying to find an equation of best fit. Okay, so for our first example, we're looking at finding a standard form equation from 3 points. So I know that my parabola contains these 3 points, 0, 0, -1, -2, and 1, 6. I don't know if any of them are the vertices or is the vertex. One of them might be the vertex, but we're not given that information, so we can't be sure that that's the case. I always like to just plot a quick sketch graph first, and let's get that going, and then I'll show you how to actually find the equation. So we have 0, 0 is 1 point, -1, -2 is another point, and 1, 6. 1, 2, 3, 4, 5, 6. So it's hard to tell exactly where the vertex might be. My guess here is that we have something that's going on like that, perhaps. It's hard to tell if this point is the vertex or not. But we do have 3 points, and we should be able to fit a parabola through them. One thing that's important to know is we have a y-intercept. At 0 on the y-axis, and it just happens to be at 0 on the x-axis as well, but at 0 on the y-axis, our parabola crosses the y-axis. So that means c is 0. So that's a really good piece of starting advice. So let's write out standard form. Okay, so that's our generalized standard form. But in this case, I know that c is 0. So I just need to work with this standard form, ax squared plus bx plus 0. So what I'm going to do is take these two points I'm being given, an x and a y, and I'm going to create 2 separate equations, and we're actually going to solve a system of equations here to determine what a and b are. Okay, so that's our goal. If we can find out what a and b are, we'll be able to write out the standard form equation. So we have a couple options here. We have an x is -1 and a y is -2. And then separately, we have an x is 1 and a y is 6. So let's write out our standard form equations for those values. -2, so using the first ordered pair, -2 equals a times x squared, which is -1 squared, plus b times x. Let's simplify that a little bit. -2 equals 1a minus 1b, or a minus b. Okay. So that is one good equation to keep track of. Now let's work with the second set of points, this one right here. 6 equals, and remember, I am just writing out this standard form right now using the information that we know of what x and y are. So 6 equals a times x squared plus b times x. And let's simplify that a little bit. 6 equals, looks like just a plus b. Okay, so we have a system of equations, and we'll be able to solve for a and b. Let me write those separately down here. We have a -2 equals a minus b, and a 6 equals a plus b. So hopefully you remember solving systems of equations, we can use the elimination method. B's are going to eliminate right away if we add these 2 equations together. 4 equals 2a. The b's eliminate. Let's divide by 2. So a is equal to 2. Okay, so let's keep track of some stuff we have so far. We know that c is 0. We know that a is 2. And we need to still figure out what b is. We can plug our a for a value equal to 2 into any other equation anywhere that has an a and a b in it. And so I'm going to use this equation right here. 6 equals a plus b, but a is 2. So hopefully you can see that b is 4. So we found a, b, and c. We found c just by logically reasoning that it needed to be 0 because that was the y-intercept. And we found a and b by plugging our x coordinates and y coordinates into our standard form equation, along with saying that c was equal to 0, and then solving for a and b using a system of equations. All right, so let's write out our solution. Y equals a is 2x squared plus b is 4x plus 0. So if we were to graph that, maybe on Desmos we could graph it and check. That graph should contain all 3 of the points we were given in our initial problem. All right, let's move on. We're going to do just one more example on this video, and that's finding the vertex form equation from the vertex and from a second point. And in an earlier video, we did something similar, but let's go ahead and do it for this one right now. So a parabola has a vertex of -2, 3, and a y-intercept of -13. Determine its vertex form equation. So I will write out the information we know. That we know h and k. -2 is h and k is 3. And we also know another point on this parabola, 0, -13. And in particular, we know that -13 is the y-intercept. That would really help us if we were looking for a standard form equation, because -13 would just be our c value. But in this case, it's not going to help us quite as much. It's going to act as just any random xy point on our parabola. So let's write out vertex form. So that's our generalized vertex form equation right there. And let's plug in what we know. So y is -13. X is going to be 0. H is going to be -2. And k is going to be 3. So we're just simply plugging in the information we know. So y is -13 equals a. And so the whole point of this is to solve for a. We know what h and k are, but we don't know what a is. H, k, and a are the 3 coefficients in our parabola, in our equation here. 0 minus h squared plus k of 3. Let's go ahead and simplify and see what we can do to solve for a. -13 equals a. 0 minus a -2 is a +2. Squared is 4. And then plus 3. Subtract 3 from both sides. I have a -16 equals 4a. So it looks like a is going to be a -4. So we have all the information we need. We have a, and we have h, and we have k, and we can simply plug it all in. So y equals our a value, -4, x minus our h value of -2. And by the way, it's a little bit cleaner to express that as x plus 2. Subtracting a -2 is the same as adding a +2, plus our k value of 3. And that would be our final answer right there. So we did it, we got through it, and that's a good place to stop.